Aloha, good morning. Um, Welcome to the Japanese Tsunami Marine Debris Mini Conference. Thanks to Kauai Community College and the Marine Option Program and Surfrider Foundation Kauai Chapter for hosting and organizing this event. We're going to come together now for Pule.
Aloha. Mahalo ke akua, mahalo ke kai, mahalo ka aina, mahalo ka lani. Mahalo for this life we all have and the beautiful lunar eclipse we had this morning and a full moon. And thank you for everything that we all have. Let us all appreciate this life that we have and every moment that we have and appreciate this conference, and please bless this conference and all the noeau knowledge that can give us. Please let us remember all the victims of the tsunami in March, the 15,000 victims plus, and tomorrow is the 9-month anniversary of this tragedy. And there is a Olelo No'eau by Mary Kavena Pokui that's Aya I Ke Ko A Ke Au, and it means whichever way the currents blow. And one of the kauna behind that is that only time will tell what will happen with all of this, but please help us all learn from the tragedy and really appreciate what we have. Mahalo ke akua, many.
Thank you. That was Zena Wetzel, who's one of our Marine Option Program students here at Kauai, and actually a alumni or alumnus of that. I'm the coordinator for the Marine Option Program at Kauai Community College, and this is a certificate program that's transferable to any UH campus in the UH system. The program has helped students, graduates, earn jobs in research, education, in resource management and tourism and many, many other jobs. If you look around the state and even the nation, you can find MOP alumni in prominent positions dealing with the ocean. And one reason it's been successful is because the program actually encourages students to work with researchers, to work with scientists, to work with the community beyond just their classroom studies. And some of those students you will see today introducing our speakers, and they did more than that, just conducting events today. They helped organize this whole event here. And they're also going to be involved, these same students, with monitoring what happens with the Japanese tsunami marine debris as it washes up on our shores, and cataloging and comparing to the present, where we don't have the debris washing in. Those students are asking for something from you. If you would like to either become a student and join our Marine Option Program, or to, as community members, work with them in helping in their efforts. Okay, so we are looking for help. All right, with that said, I'll move on and let our students do the talking, and we thank you again for coming.
Please welcome our first speaker, Dr. Nikolai Maximenko, Senior Researcher, Affiliate Researcher of Oceanography at the International Pacific Research Center and the School of Ocean and Earth Science and Technology at the University of Hawaii.
Thank you very much for a nice introduction. Aloha, everybody, and thank you very much for inviting me. It's a great honor to be here and to see people of Kauai, and it's also, very, very, very nice trip. It's the shortest possible flight from Honolulu. So let me try to start my presentation. Okay. Mm-hmm.
There are some seats up front for those of you who are in the background. They're front row seats, middle,
First of all, I'd like to acknowledge my collaborators, Jan Hafner, who is continuously working with me on all projects related to marine debris, and remote collaborators from JPL, NOAA, AOML, and from Scripps, Luca Centurioni, Rick Lumpkin, Ichao, and others. So.
Pardon me, I apologize for interrupting, but I just want to make sure if there's anybody who needs some hearing amplification, who has any hearing impairments, we have devices to accommodate them.
I would really like to close captioning. Those will do me any good. Those will do me any good. Do you have closed captioning? I'm sorry, we don't have closed captioning. That really pushing. Right here. I apologize. We have signing and we have those are options.
But those captions can be on. It's easy to do, especially see it.
Okay, yeah, I apologize. I don't have captioning. Next time I will think about that. But please let me know in advance. Okay, thank you. So why we're here is, of course, because that disaster that happened on March 11th in the northern part of Japan, in the Pacific. Unprecedented, huge tsunami was generated by the earthquake, and now people are working on estimating what actually happened geologically and hydrodynamically in the ocean. And recent studies, they show that during the earthquake, bottom of the ocean in some large area shifted horizontally by 50 meters and uplifted by 10 meters. But in addition to that 10-meter vertical motion, because of the tilt, because of the slope of the bottom, horizontal shift, 50-meter shift, it added another 16 meters to vertical heat from underneath. This induced a huge wave, and then bottom topography in that area, it produced so-called mergent tsunami that amplified the amplitude, amplified the wave. And then I believe you all saw these pictures, and actually they may be a little bit misleading. They remind somewhat like wind waves or swell that we have in Hawaii every day, but they are not. In fact, what tsunami is, it's very long wave, hundreds of kilometers long, that moves very fast at speed of jet. And then as it enters shallow waters, it slows down. So its frontal edge slows down when tail still moves very fast. So it increases in magnitude, and then it comes as kind of bore. So it's like a jump. And then this wall, it hits the shore, and it goes on and on and on, as you saw on Japanese TV news. It floods vast areas, and then and on the way it breaks everything that it can break. And but it does not end there. All is mixed together, and then water retreats. And that retreating water, it pulls into the ocean whatever it can. As you probably know, Japan lost 15,000 lives during that tsunami event, and it would be much worse in any other country. Japan is prepared for earthquakes, but not, it did not work perfectly for such outstanding earthquake. Rate of lives lost was 10%. They say only 10%, because for comparison, Sumatra earthquake in 2004, death rate was 90%, and it was comparable. So even though protection, the wall that Japanese built to keep this area safe, and forest that they planted along the coastline, it did not really work. But what worked is warning system and education system. So people knew once you hear something, they run away. And we should learn that from Japan. We should learn how to do that. So again, I believe you all saw this terrible shortage and shortage. And but then, what happens after tsunami? As I mentioned, tsunami washed into ocean large amount of debris. We do not know exactly the total weight or volume. The amount of debris that was generated, that was induced by crashing all these villages and towns, is estimated by Japanese government to be close to 20-25 million tons. So this adds all this construction material and all these household items. And we have reasons to believe that 1/3, 1/4 of that amount was probably pulled, dragged into the ocean. So if you ask yourself what could be in the ocean, just look around. Whatever you have in offices, whatever you have at home, it could be there. And in addition, whatever they have in ports, and plus fishing boats, and this is also area of active aquaculture. So nets, floats, etc. What can we do? What can we do to assess the motion of that debris that was washed into the ocean? Not much, but we can do something. Debris was seen only during first days, during search and rescue operations by Japan Coast Guard and U.S. 7th Fleet. And that is when debris was close to the coast. And at that time, debris was floating in form of thick yellow mats. Yellow because main component was lumber, wood from broken houses. And you probably know some stories of some saved lives and saved animals. But a few weeks, and at that time, consequences of the earthquake and tsunami, they were seen on some particular images from NASA and international satellites, both on land and at sea. But a few weeks later, debris disappeared. Debris in the ocean disappeared from our screens. It disappeared from photographs taken from airplanes. It disappeared from images taken with satellites. So it was really not clear what's going on. There were a few possible explanations. One explanation is that most of material would finally sink down, and it's not clear how fast would it be happening. For example, if lumber is softwood, people were speculating that, okay, softwood would absorb water and submerged and finally sink down within a few months. Also, all kind of ocean currents and waves and wind, they would pull away, they would disperse originally compact mats, so that those mats, they would cover larger area, but they would become more sparse. And this is probably the main process that is that took place. The data. The best data that we have from the ocean is probably trajectories of so-called drifters, drifting buoys. Here is the schematic of such standard buoy, and it consists of surface container, surface float with satellite transmitter and large drogue, large sail attached, reaching 18 meters depth. And location of satellite transmitter is detected by satellites, and because of this large drogue, drifter is moving together with water. So it's mainly carried by ocean currents. And for 20, 30 years, we were using this tool to measure surface currents. And only recently we started using it to understand trajectories of marine debris, which is related but not exactly the same task. So for now we have about 15,000 trajectories of such instruments, and it would be easy task if we had such buoys, such drifters sitting right on the debris. But unfortunately, at a time of tsunami, you can see the global coverage of this program. There are between 1,000 and 1,200 buoys maintained in the global ocean at any time. But unfortunately, on that particular week of tsunami, there were no buoys in the area of Sendai, in the area east from northern Japan. So we need to do some smart analysis of existing data to predict how that tsunami debris would move in future. And for that, I will skip many technical slides just to keep it short and to keep it comprehensive. We developed a statistical model that computes probability of motion of debris. And then with that model, we can run different kind of experiments under different scenarios. And in this example, we deploy model particles, model debris in the area of tsunami, and we can see how ocean currents and winds, how they would carry it around the ocean. And you can see that, okay, it generally moves eastward. It also increases in the area because of this horizontal mix and dispersion. And then it moves just north of Hawaii, and it touches Hawaii with its southern edge. And then it hits west coast, and finally it recirculates into the area between Hawaii and California. This is famous area of North Pacific garbage patch. This is the area where surface currents converge, and this is the area where all debris from entire North Pacific ends. This area became famous some years ago, actually about 12, 15 years ago. So if now I show maps for every year, 1 year, 2 years, 3 years, 4, 5 years after tsunami, then this is what we can expect. From that model, most probable prediction is that 1 year after tsunami, southern edge would touch Midway Atoll, and then 2 years after tsunami, it would touch Hawaiian Islands, and then between 2 and 3 years it would reach west coast, and then after 5 years it would end in that garbage patch. But again, this is based on all data for recent 30 years, pulled together, mixed together, and processed in some statistical way. Every year is different. We know that. We have El Nino, La Nina, we have winters, and we have summers. And so can we do something more realistic? And yes, we developed another model. And this model uses two kinds of satellite data. I will not go into details, but satellite altimeters, they measure pretty accurately shape of sea surface, and shape of the sea surface, it works the same way as pressure in atmosphere. So when you look at weather maps, you see highs and lows, and you can decide about weather conditions. Same thing in the ocean using sea level data, and also satellite winds. And these winds, they add another component, so-called wind-driven component. It's not just waves. It's not just Stokes drift induced by those waves, but it's more complex spiral, rotating spiral with depth. It's so-called Ekman currents. And again, I will skip this part. Here is example of our surface currents. So we are updating, we are running this model every day, and we are assessing surface currents every day. And these are currents for May the 9th of this year. And this particular day was computed because we were contacted by Humpback Whale Sanctuary. They had their gear drifting just 20 miles north of Kauai, and they asked us how much time do we have to rescue it, and we looked at this and we saw that strong jet, and we said you don't have any time at all, and they didn't have resources, so 1 week later it was 200 miles away. But I think it was, the end was good. Coast Guard, I think they rescued that particular gear. And then near Midway, there was another float, experimental float by JPL that was failing, and it was later rescued as well. So using this model now, we can run experiments under more realistic conditions corresponding to this particular year. We are updating this model solution every day, and it's public. It's available on this web page. If you don't catch this pretty long line, just get in touch with me. I will send it to you. So every day you can see where our model thinks it is now. So you can see pretty complex process of kind of propagate, advection, stretching, stirring, filamentation, many signs of small oceanic eddies, also some atmospheric impact. This is our assessment for location of tsunami debris for today. So what we see here is that it is pretty close to Midway. It extends nearly to longitude of Kauai at some more northern latitude, and it's interestingly it also there is still some debris close to Japan, and in fact there is some motion of that debris towards Japan. I will try to talk about that next. So our model is based on our previous knowledge. Whatever we are doing, it requires continuous validation. It's like weather forecast. Do you trust weather forecast for tomorrow? Probably yes. Would you trust weather forecast 8 months from now? Probably no. Although, you would probably trust that, yes, winter is coming. Next year may be more dry than this one, or some predictions of long time, low frequency variability. Same way we were running blindly our model, and we were not sure how truthful is our outcome. So this is okay. I will skip this. First confirmation of the existence of tsunami debris in the ocean. It came only at the end of June. Two sailors, they were sailing from Yokohama to Alaska, Kodiak, and they were sailing across tsunami debris, across a field of unusual debris for 2 days. And they sent messages to their friends, and then friends forwarded their messages to us. And in their short anecdotal report, they mention a lot of lumber. They mention freezer chests, file cabinets, styrofoam, and household items, other household items. This is a good example how we are not prepared to monitor this kind of debris. They were sailing for 2 days. They were surprised enough to send emails. They were not surprised enough to take any pictures. We were chasing them for 2 months. After they finally returned to their home in Seattle, it was frustrating to find out they don't have any samples. They don't have any any pictures, only a few lines of these reports. Then again another period of silence, and then we've got another opportunity, again very random opportunity. Russian sail training ship stopped by Honolulu with a visit, and it's a beautiful ship. We met with the captain. We told him about the problem, and he's got concerned. In some sense, he's got scared, because he was going into that area and he did not know anything about that. And unlike huge cargo ships, these ships, they are not as safe. And in addition, unlike commercial ships where everybody is busy, people are making money, people are busy. On this training ship, they have 150 pairs of young eyes of cadets, students, trainees, who are curious and who can keep their eyes in water. So next day I flew to Europe, and I didn't know what's going to happen, but it happened that the owner of that ship suddenly requested the ship to return to Vladivostok, and they changed their route, and they went all the way across nearly the center of tsunami debris, from Hawaii through Tsugaru Strait here. So this line, it shows where they started seeing debris, and it was only, at that time, it was only 250 miles northwest from Midway. Then, at some location here, 400 miles from Midway, they picked up 20 feet long fishing boat. And that boat had Japanese markings. And after some research, they found that it was registered to Fukushima prefecture. So it definitely came from Japan. It definitely came from tsunami area. And jumping a little bit ahead, recently I was told by one Japanese TV company they were able to locate the family of the owner. So now they are developing this story further. Again, they took many pictures of that boat, but even when they were prepared to observe debris, all their information was only about boat, and all other information was again just anecdotal. And again, it was pretty similar to what we heard before. Lumber, household items, appliances, TV set, fridge, and so forth, and smaller objects, wash basin, drums, boots, bottles, and so on. After this experience, we started developing collaboration with as many sailing boats as we can. Now, this another Russian sail training ship belonging to the same owner, they are now in Tokyo. But on the way from Hawaii to Tokyo, they were monitoring the southern area of that tsunami debris field. We were not sure whether they will be able to see something, but and weather was not so good. It was stormy, and once it gets rough, it's really difficult to take any observations, because you cannot see much, you cannot see far. It becomes dangerous, and also waves, they mix floating objects, they push them underwater, so they are not as well seen as at low sea. But here, the object that you can see, it's an entrance door, and I do not see any reason anybody would throw entrance door into water if it's not broken by tsunami. So again, another confirmation. But we continue working, and we hope to have aerial surveys. We are talking to different companies, agencies, partners, still it's difficult. We were not prepared for this event. We do not have observing system in place that would, be ready to follow such objects in water at any time. And this is something that we should work on. And partly we are here because I want to tell you that you have opportunity, and I hope you will become a part of this future system. Because this tsunami event, it's a tragic event, but it's also for us unique opportunity to understand how it works, and also to protect ourselves as much as we can. So now this winter we expect debris to come on Midway, then on Northwest Islands. Then Kauai will be probably the first island affected by tsunami debris, the first main Hawaiian island, and then others will follow. So by comparing between the times of arrival and also by comparing the composition of debris, we must be able to learn a lot. So I hope this conference will help to establish, future collaboration and future communication with people, with the boaters, with people going on beaches, with people doing cleanups, or just with people keeping their eyes open. So let me skip this part that illustrates differences between different years. And let me go to somewhat, maybe a little bit more optimistic part. As a scientist, of course, when I run some model, I want this model to be correct. I am kind of ready to defend what I am suggesting. But once we started talking to reporters, I started receiving phone calls from local people. So people running local business, especially associated with tourism. So there were phone calls like, okay, we are in the middle of long economical crisis, and now after tsunami we lost 10% of Japanese tourists, and now what? Garbage is coming on our beaches, so should I just close my office here and move on mainland? And this works as a cold shower, and this makes us to feel responsible, and keeps us, more objective. So first of all, this tsunami debris, yes, it is going to be kind of anomalous event. We do not know how bad will it be, but it's not something new. It's debris, marine debris, is not something that did not exist before that tsunami. We have a lot of debris here in Hawaii. Many of you probably know that, especially windward sides of all islands. Also, we are just next to that garbage patch, and let me skip to this. I will come back. After that, our study shows that if ocean currents and wind and atmospheric winds were steady, then debris would be collected in the middle of the ocean, and maybe we would not know much about it, and maybe we would not care as much about it, although it's not a good excuse. But what happens is everything changes, and there are many different kinds of variability in the ocean, starting from storms, oceanic eddies, seasonal cycle, El Nino, La Nina, Pacific decadal oscillation. Such change, it shifts and changes the shape of that garbage patch. And from what we see from trajectories of drifting buoys, every time when drifters are able to leave from this area of garbage patch, it never goes towards California. They always move towards Hawaii, and they end on our beaches or they just sneak between islands and return back to the garbage patch until next time. That's why we say that Hawaii is the final destination for marine debris. So this problem is very important for Hawaii, not only in connection to that tsunami. We are we are living in the area where this plastic from entire North Pacific ends. And we don't know exact numbers, how much plastic, but maybe most accurate estimates they provide between 1 and 3 million tons of plastic in the North Pacific. But it's difficult to say how confident is this estimate. So as to some kind of good news, when you read in newspapers 20 million tons of tsunami debris are going to hit Hawaii and West Coast, this is absolutely incorrect. So most of that debris is going to stay in water. Look at this. After 5 years, 95 to 99% of tsunami debris is still expected to be in water. Only a few percent will go on coastlines. Still, this amount is larger than we have every year from just other sources. So, and also tsunami debris is somewhat different kind of debris. It may be more dangerous because what they have in harbors, it's different from what people throw in ocean every day. So. Another good news is that when we are running our models and we analyze our data, we start seeing some pathways, something regular, something robust in motion of debris. So now instead of dealing with this huge turbulent area, now we are suggesting some particular pathways, like on this slide. You see this kind of corridor. All particles that start from Sendai area and end in Midway area, they all follow this pretty narrow path. And this means that even with limited resources, we can explore this path, we can monitor this path, we can drop satellite markers, and hopefully we can clean up this path, at least from particularly dangerous objects. And let me just quickly say a few words about Kauai. As I mentioned, every year is different. This diagram shows amount of debris that would show up on Midway Atoll if tsunami happened in different years, on March 11th, but not in 2011, but different years. And from that, you can see that mainly peak of that impact occurs in winter, but some years are anomalous. And once it reaches Midway, then our models become then it becomes more complicated to predict what's going on, because it enters this area of Hawaiian Ridge, which corresponds to area of very strong tidal mixing, very strong currents, and this is the area that still our instruments, our theories, and our satellites, they cannot really simulate and monitor. So, Kauai is the first island in that along that line. So, what can you do if you want to contribute? What can you do? It's good time now to set up some reference observations to see what is now on the shore, on particular beaches, on particular coastlines, so that when something unusual is coming, you will be able to distinguish that. Also, there are some relatively, I think, simple tasks that needs to be done. For example, we still do not have many tools. We do not have efficient tools to monitor debris remotely or from aircraft, except for derelict fishing gear. And this is brochure published by NOAA about 2008 survey of main Hawaiian Islands, and this is the map of Kauai, and you can see how heterogeneous distribution of derelict fishing gear detected from the aircraft. Most of it is along east coast and practically nothing in the west. So it would be very important to see whether this data only reflects these large objects such as fishing nets, or whether in the same areas you can see accumulation of all kind of debris, bottles, spacer tubes, hagfish trap cones, microplastic, this plastic sand. So if somebody could do this, this would be of great help for future advancement. And I think I will stop here, and I will answer your questions if you have any. Thank you very much.
So we're just going to have a short question-answer period after each speaker. And if you want to repeat the question that they asked.
Thank you for being here. Are there commercial shipping lines that currently go through the area that you showed?
Yes, there are many cargo lanes, and I believe there are many fishery ships.
Set up where they can accept volunteers to help in monitoring, since they're regularly, transiting those corridors?
For now, it does not exist. I mean, okay, I'm not sure everybody heard the question. The question was, are there many commercial ship lanes across that area, and whether there is collaboration with them, and whether collaboration is possible, correct? So right now, I don't think there is such collaboration. I don't know about it. We are trying to establish one, and it was kind of puzzling that they do not see much. They do not see anything, and they do not report anything. And that was a puzzle to me until I visited one cargo ship. And you can imagine, it's huge ship. It's like 10-story building. And there are only 30 people working around the clock. And they are really busy and tired, and each of them has particular duties. And then they are really big. They do not need, for their business, they do not need to look out. They have everything inside. And but even if they look outside, it's too far from water surface. It's too tall, and also it moves too fast. So it is difficult to ask them to do extra job. At the same time, they are open for collaboration. Right now, actually, these days, we are talking with EPA, who are going to sponsor some small project during which we will be analyzing content of filters, engine filters of cargo ships. The idea is that ships crossing all these areas, they will collect pieces smaller than 1-2 inches and larger than 1 millimeter, and from that we can learn something. Some companies are also ready to would agree to have cameras, high-resolution cameras, installed on their ships, and this is a big difference from previous decades. But problem is cameras are cheap, but analyzing images it's really difficult and expensive. So it needs to be either a big program or it's not worth it. So, but we are working on that. And in addition, some cargo companies like Metson, they are and Horizon Lines operating in Hawaii. They are interested and they are open to environmental assessment. They are interested in contributing into environmental studies, and I think sometimes they are willing to provide some sponsorship. Like in our case, Horizon Lines, they helped to get equipment from California free of charge. That was a good help.
Will there be any danger to individuals who are removing the debris from the beaches?
Would be dangerous would it be dangerous to remove debris from beaches?
Would there be a danger to those individuals?
Radioactivity. Okay. Henrietta is going to talk about that. I think I will leave it on you, right? So as to radioactivity, Henrietta Dolayova will be next speaker, and she will talk about that. As to other kind of danger, there are already groups that are doing cleanup, and they have experience, and they have some simple enough equipment that they need, and sometimes not so simple, because some nets, I think Kerry can tell more. Some nets are heavy and bulky, difficult to pick up, cut, transport. And are you going to talk about reef cleaning? The reef cleaning? Yes. So Kerry is the right person to answer this question.
Are there other governments that are willing to help us clean up this mess from other countries?
Our government?
Other
Other
governments.
governments. Well, okay, let's compare with Japan and US. The question is, are other governments willing to help us to clean up this mess? Let's compare Japan and US. Japan was hit by tsunami. A large area was devastated. They lost 15,000 lives. Tens of thousands of people are still in shelters. They lost a very important nuclear power plant. So they are short in electricity, and they are at the end of very long economical crisis. And they have their coastal area polluted and destroyed. And so, okay, will they care? Will be their priority to think about that debris drifting away from Japan? And let's compare to us, to America. Now, okay, yes, we are in the middle of some depression or crisis, but it's coming to our shores. We must be concerned. And what are we doing? I would say not much. So I would expect it's more logical for us to be active. But I want to say that in fact Japan is after some period of taking care about urgent things, now they are starting analyzing. They're getting more interested in that tsunami debris at many different angles. And one angle is, yes, I heard that in Japan. People in Japan say it's shame that our Japanese debris will pollute somebody's shores. Our government should take care, should do something. So something is starting to develop, but it's pretty slow.
Yeah. Is there any similar analysis or concern of this sort of phenomenon following the Indonesia tsunami and '04? I mean, was anybody concerned about the debris from there? And was there any assessment of that?
question is whether there was any similar analysis performed after Sumatra, Indonesian earthquake and tsunami. It's very interesting. No, I do not know such studies. And actually, we discussed this question in our group a number of times, and we are going to do that as soon as we have time. Now we are just overwhelmed with Japanese tsunami, but we do not know why that has not been done before, and we do not know why there were not many reports about debris from Indonesian tsunami. One my possible explanation, speculation would be it happened in the northern Indian Ocean, and normally floating objects, they do not cross the equator. So equator works like a wall. So it was limited, restricted to pretty small area of Bay of Bengal. It could move, but one other thing, it's just a speculation. It's really overpopulated area. So every time when our drifting buoys, when they enter area of Indonesian seas, they just disappear. They are recycled without absolutely down to tiny nails. So maybe that debris was just reused instantly. So I do not know. But we are going to do that.
In your opinion, when are you expecting the debris to actually be here, according to all these studies? What would be your guess?
Well, I'm trying to be not just cautious, but kind of trying to provide some kind of grounded opinion. The earliest until recently, well, we expected it to be in September. After report from Pallada, we expected that it should be already, in December, it should be already on Midway Islands. It's not there yet. It's not there because currents changed, and now what we see around Midway flow is generally from south to north. And actually we see some debris, but it's either hard to say whether it's from tsunami or not. It's like plastic containers. It's something not unusual. Or it's something that came from tsunami and recirculated, so now it's coming from south. It's difficult to say. Different kinds of debris, they also drift a little bit differently. So I'm still pretty confident that we are going to see that debris on Northwest Islands this winter or the latest next spring. But I cannot tell exactly when and what. Thank you. Yes, there are a number of. Okay, question was if volunteers are going to help on beaches, is there some protocol for observations? In fact, there are a few different protocols, and depending on how carefully you want to do that. You actually have a broad range of protocols. We are now circulating a simple form, and I have some with me for people who do not do that all the time, but just spotted something unusual and want to report that. Very short form. And you can mail it to me or give me a call or send email, and you don't even need stamp if you don't have time. I will pay for that. But NOAA has longer form if you want to provide information that may later become a part of a larger archive. And by the way, we are now using this simple instrument, which is just a piece of wood. We are dropping these pieces at different locations, and there is contact information that leads to Hank Carson in UH at Hilo. So, in the back or on the side, you will see some number. So if you see something on the beach, please remove it from water and report. This is very important. We are already receiving very interesting information, some surprising, and we hope to get more from you. I think I overspent my time. Thank you very much.